A reverse proxy is a surrogate server. It appears to be a client to an ordinary web server. However, in reality, it's just an intermediary that forwards the client's request to the real ordinary web servers. If you use it together with another technology, SSL termination or TLS termination, it will be even more powerful. In enterprise network environment, it plays a crucial role when it comes to load balancing, and even for home user, it can also achieve great benefit. So in this video, let's discuss how we can use UniFi gateway in a home network environment, how to construct reverse proxy with SSL termination. Let's first talk about without using reverse proxy, how you can achieve similar goals. In your LAN, you have two different services. You want the external clients to be able to connect to them. So let's say first one is a web server. It uses port 80. The other one, let's say it's a FTP server, which uses port 21. You have a domain name, which is associated with the public IP address of your UniFi gateway. Then how you can connect to the two different services by using one public IP address from outside world. You can do port forwarding. Depending on the nature of the service, you forward the client request to different LAN servers. Port 80 forward to web server, port 21 to the FTP server. This is the natural easy way, right? However, what if you have two servers but they are both web servers? By default, they use port 80. But if you want to use the same port forwarding approach, they have to use different port, which means you have to create two port forwarding rules, and your client has to spell out which port it wants to use. In this example, one explicitly specify 80, the other one 8080, right? This is not user friendly and it's not an ideal approach, but it will have its job done. If it's just your internal servers, you don't worry about the trouble of specifying ports. Then there's a way it can perfectly resolve the troubles we just talked about. It's much more flexible, and you can also achieve SSL termination. Okay, your UniFi gateway, it still has one and only one public IP address, but you use dynamic DNS, you update the DNS record so that you have two host names associated with your domain name. And your clients, they can all use regular HTTPS, but within your LAN, you run a reverse proxy. The reverse proxy will do two things: forward the request to different servers depending on the host name. It can use HTTP instead of HTTPS. You are doing the SSL termination here. Of course, the benefit of doing SSL termination is you only need to worry about managing the certificate in one single place, which is the reverse proxy. It will reduce the resource consumption for your servers. In this video, we will dig in details about in each single step what you can do in a UniFi network environment. There will be 4 major steps in this video. First, configuring the DDNS. Second, doing port forwarding. Third, using Let's Encrypt to manage certificates. The last step, the most important step, to set up reverse proxy. The first and second step, they are functionalities directly supported by UniFi gateway. But for the third and the fourth steps, unfortunately, Ubiquiti still doesn't have default supports. So we have to use an external Linux machine to set them up. Okay, let's get started about the first step, DDNS. In this video, we don't have time to talk about the detailed dynamic DNS setup in UniFi gateway. If you are interested, check my previous video. I use Cloudflare to register my domain name and to support DDNS. So you can see at this moment in Cloudflare, for my domain name, there are no any custom DNS records. In UniFi gateway, in settings, internet, for this primary one part, if I go to menu, then you can see the dynamic DNS option. Click on create new. Let me choose Cloudflare. Then for API token, I have already created one in Cloudflare beforehand. So here I simply paste it. Then for zone name, I input the domain name I registered with Cloudflare. Then for host name, let me say srv1 dot, then followed by the zone name or domain name. Okay, I'm done. That's how simple it is. Click on create. And here, even without clicking on the apply changes, go back to Cloudflare. Let me refresh. See, a new A record, address record has already been created and with the name SRV1. I'm good about this one. Then create another one in the exact same way. Here for host name, I say srv2 dot, then followed by zone name. Create. Then go back to Cloudflare, refresh again. See, there are two A records. I'm good. Apply changes. We are done about the very first step for DDNS. I can go to a terminal to validate the two host names. First one works. Second one also works. Okay, perfect. We are done with the first step. The second step is to configure port forwarding. Even though I have two backend servers, when it comes to port forwarding, I only need one rule, which is forward to the reverse proxy. So let me create one. Name it as forward to reverse proxy. Then for one interface, primary one part. Let me say 443 because I want the service to be HTTPS. Forward IP address, I need to use this reverse proxy's IP address. In the lower left, for this Linux machine, I plan to install reverse proxy later. So let me get its IP address first. Okay, it's .2.178 as I noted down already in the slide. So let me input it. For the forward part, I want to keep it as 443. For protocol, no change. Just for testing purpose, let me enable the syslog login add. At this moment, yes, I do have a port forwarding rule. It does forward the request if the port is 443, but because the reverse proxy hasn't been configured yet, of course, it will fail, right? But at least we can test whether the port forwarding happens or not, right? In the lower right terminal, let me SSH to my gateway, which is a UDM Pro. Then go to a folder under var log and then ulog. You can find a file called syslog emu.log. This is the internal storage for syslog. So let me use tail command, monitoring the change of the log. Now there's nothing. Then in the left side, a random internet client. Let me run a curl command against the host name we just configured using DDNS, the service one dot something, right? Let me run it. Of course, it fails because we don't have any service in the reverse proxy, right? However, the purpose I run this one is to test whether the port forwarding works or not. So remember, we enable the syslog when we configure the port forwarding, right? In the tail output, we see two logs generated already. Basically, they are both from the IP tables, net table. One is for pre-routing DNet, the other one is for post-routing masquerade. Okay, so that means the port forwarding was successful. We are done with the second step. Let's move on to the interesting third step. Let's encrypt. Thanks to the Let's Encrypt service and various free plugins to support different service providers, now to generate a certificate is very easy. So in this lower left Debian Linux machine, let me run this command to install certbot and a Python tool to support certbot, and it's related to Cloudflare DNS service. Before Let's Encrypt can generate a certificate for you, it needs to make sure you own that domain name. So there are various ways to make it happen. This Python tool will work with Cloudflare so that even when you run the certificate generation behind your firewall, it doesn't matter because the challenge is done in the DNS server side in Cloudflare. So let me first install these two tools. After installing the tool and the plugin, we need to prepare a Cloudflare specific configuration file to be used by Let's Encrypt. So let me edit this file under the etc Let's Encrypt folder. What you need to do is to provide a API token. If you want to know the details about how it works, you can read this certbot DNS Cloudflare documentation. It explains the DNS 01 challenge, which involves creating, removing a TXT record using Cloudflare API. So in this video, we are directly utilizing the plugin to accomplish this. It need a API token to do that. So you can use the exact API token when you configure the DDNS in the very first step. My editing is done. Let me save it. Okay, we have this file ready. Because this INI file contains the API token, I want to secure it so that only the owner can read and write. Let me run the chmod command with 600, right? Finally, I'm ready to run the certbot command. I only want to generate certificate and I want to use Cloudflare DNS. And here I specify in this INI file, which I just prepared. In this file, I want to prepare the Cloudflare credentials. The very last part is the domain name, which I want to generate a certificate for. Okay, let me run it. Okay, see, it's successful. Then run the command again against another domain name, srv2, in the exact same way, right? Okay, successful. Before finishing this third step, let me show you the certificate location. Go to etc, let's encrypt live. I need root access. Okay, I'm in the live folder. You can see for the two host names or domain names, they have the corresponding folders for each of them. And if I cd to any of them, for example, srv1, you can see the different files. Okay, and the last thing, let me show you what certbot did to automate the certificate renewal. So let me run system control list timers. You can find there is one timer specifically about certbot. And if you want, you can run this command, certbot renew, to force a renewal. Okay, I'm not going to run it in this video. By the way, if you don't want to generate different certificates for different host names, you can generate a single one for wildcard domain names. Here I have two -d parameter values. The first one, star dot, then my domain name. The second parameter is the domain name itself. So in this way, this certificate will cover the wildcard domain name. First, let's install the reverse proxy. The very popular choice is Nginx, which is a popular lightweight web server and reverse proxy. In the lower left reverse proxy Linux machine, let me run sudo apt install Nginx. Okay, it's already installed. Then let me go to the Nginx configuration folder under etc Nginx. You can see there are two folders. Start with sites. We need to deal with both of them. First, let me go to the sites available to start the configuration. You can see now there's only one default file. And let me edit the first configuration file, which is the first server. So in my case, the name should be srv1. So let me edit the file, vi srv1, without suffix, just srv1. Okay, this is the content I have typed in. There are two server sections. The first one is listening on 443 for HTTPS. And here I need to specify the complete server name. Then I need to provide the certificate and the certificate key location. As I showed you earlier, it's under this Let's Encrypt live folder with the complete domain name, and the certificate has the name full chain. The key has the name private key. And next, I need to specify this part, which is pointing to the local server. So I need to provide a proxy path, and here I specify HTTP. I don't want to waste the compute resource in my LAN. to support HTTPS, so it's just HTTP. And then the IP address in the right side, I can easily get IP address. Okay, it's .2.183. Then the following 4 lines, you can keep them in the same way. It's just the regular setting for proxy set header. Then this ends the first server block. The second server block, in my case, I don't really need it. The reason is when I do port forwarding, I only configured port 443, which means even if the client type in HTTP instead of HTTPS, it will fail. But it's just a good practice to keep this way, just in case you do open up port 80, the system can still force the use of HTTPS. This is the simple configuration within Nginx just to support the first server. Now I need to save it, but I just realized I didn't use sudo when I run the vi command. So let me use this way. I want to write, but I want to use sudo. And then, okay, write it. Okay, it's saved. I need to create the second one for the second server. Let me simply copy the first one to the second one. I need to use sudo. Then let me edit the second one. And this is the easy change. I simply need to change server 1 to server 2. That's it. Of course, for the IP address, I need to get the IP address. It's .2.170. Okay, changes are done. Let me save it. Now I have 2 configuration files created under the sites available folder, but they are not effective yet because they should be in the other folder, which is called sites enabled, because we don't want to simply duplicate them. So I can create link in the sites enabled folder. So to do that, I run ln command. This is the source file which I just created. This is the destination folder. Run it. Then for the second file, run the same. Okay, now if I go to the sites enabled folder, you can see I have these 2 links created successfully, right? You know what? I'm done in the Nginx side configuration already. So let me validate the configuration using Nginx. Let me run sudo nginx t for testing. Okay, everything's fine. Then let me run system control to reload Nginx. Okay, done. And before we testing it out from a real internet client, let me go to the 2 servers locally. Let's see what's their homepage at this moment. Go to the server 1. Let me run curl http localhost. Okay, it's successful and it returned the home page, and you can see there's a text called welcome to test 1. Then if I try the same in server 2, okay, and the text is different. Welcome to test 2. Okay, from the real internet client, we should be able to validate whether the reverse proxy works or not. Now the exciting moment, let me go to internet client. Let me try this first HTTPS link. Here, I need to use the real valid internet domain name. See here, this is my domain name. This is the first host name. And here I want to use HTTPS. In the client side, I didn't do any configuration. All the certificate, the reverse proxy configuration were done within my LAN. I need to do nothing from the client side. So let me run it. Okay, see? The text is welcome to test 1. Then let me run the second server, which is service 2. Okay, the text is server 2. We are completely successful. And if you just wonder whether I'm just lucky the system happened to hit the correct backend server, I can try a non-existing name. Let's say SRv3. Okay, cannot resolve, right? Then let me do the last testing. Try to use HTTP instead of HTTPS. So let me visit the first service. From the return, you can see it is returned from Nginx, right? And it does return the 301 to redirect. In fact, the return you see was not from the Nginx running in the LAN for the service 1 at all. It is the Nginx server running on UniFi gateway for the UniFi web UI. So we can prove that if I go to SSH for UDM Pro. Let me run this command to show you all the processes which are listening on port 80. You can see the very first one, this Nginx in UDM Pro is listening on port 80, right? So this is why you see return. This is not due to our port forwarding. Okay, just to clarify it. Now let me use browser to make final validation. First try HTTPS using the server 1. Very fast, successful. If I change to server 2, okay, successful, right? However, let me validate the HTTP. Remember, I don't want to forward port 80 to my Nginx server, right? Let me try it. Let me use HTTP and for server 1. Strange, it's successfully redirected to server 1. That's alarming if the system really forward port 80 as well. Let me confirm that's not the case. So in the lower left, in SSH session to UDM Pro, I'm already in this system log folder. Let me run this command to show the syslog in real time. At this moment, nothing happened. Then just to avoid the impact of browser cache, let me use the private mode. It's in private mode now. Then let me try to visit the URL with HTTP, not as run it. Okay, you see the browser is hanging there and nothing's happening in server side yet. Let's wait. I believe now the system simply cannot successfully finish the request, right? And then see what happened next. Now it's successful. However, if I try to show the certificate, see, Safari is using encrypted connection. Why is that? Let's validate in the lower left. So you can see from this port forwarding logging, the destination port number is 443, right? Which means the system is using 443 and there's nothing wrong in the port forwarding. So what really happens is in modern browser, if you accidentally use HTTP, the browser will try to use HTTP without encryption. But if it fails, the browser will make another try by using HTTPS instead. So this is done purely from the client side. So nothing's wrong in the server. The port forwarding still forward 443 and our reverse proxy only react to 443 in my configuration for this video. Okay, we are good. It's time to end this video. There's one last thing I want to mention. In step 3 and 4, you may notice I use the command line tool from Let's Encrypt and Nginx to configure the certificate and the reverse proxy, right? If you search internet, it's very possible you can find much more user-friendly wrapper, so you don't really need to do that in backend. But my philosophy is if I can easily achieve the same thing using the basic command line tool in backend, I will prefer that way. It's just my choice. Okay, this is the end of the video. Thanks for watching.